So good day to everyone. My name is John Camilo B. Dichosa, and today I will be presenting to you a presentation about manometers. So first of all, what are manometers? Manometers is a type of scientific instrument that is used to measure uh, different levels of pressure using a gas or a liquid in a U-shaped tube filled with a fluid such as mercury or water. It operates on the basic principle of hydrostatic equilibrium, where the difference in between two columns heights corresponds to the pressure difference being measured. So, um, next is we have what makes up our manometers. So one of the formulas or one of the equations that make up our manometer is absolute pressure. So absolute pressure is a measurement in the amount of force that is exerted in a container by an object or a fluid. It is usually described in the equation as seen, which is equal to P is equal to rho GH, where the our big P or our capital P is our pressure or absolute pressure. Our rho or small letter T is the density of the manometer. Our G is our acceleration due to gravity, which is 9.81 meters per second squared. And H is the height difference between two fluid columns. So another formula we have for absolute pressure is P absolute pressure is equal to P atmospheric pressure plus or minus the delta T or the difference in P. So next we have the types of manometers. We have four different types of manometers. So first one is a U-tube. So a U-tube is a column that is usually filled with reference liquid, usually mercury, to display the difference in pressure levels. When the columns of the device are exposed to the atmosphere, the liquid levels in the limbs are equal, indicating the atmospheric pressure or the presence of atmospheric pressure. Next is we have the enlarged leg. In this type of manometer, the float is seen in the enlarged leg that is used for noting or indicating the differences in pressure. In an enlarged leg manometer, there are two legs that can be changed for changing the span of measurement. After this is we have the well type. A well type manometer includes a large well in one of the legs. Another leg just features a simple tube. For a minute change in the displacement in a well type, there will be a large change in the height of the tube. Well types are usually used when there is a greater amount of change that is usually seen in comparison to U-type manometers. And usually the ratio between the well to the um, simple tube that we have is usually 10 is to 1. Lastly is the inclined tube. The inclined tube is, as said, is inclined, so it is slant. It is a slant-shaped manometer which has a 10-degree angle for the measuring leg. The sensitivity of the device is improved along with its inclination, and the manometer is usually used to measure the small differences in pressure. So next, we have the different uses and applications of a manometer. So um, for our first use and application, we have on the upper left the package HVAC system. So HVAC systems usually measures and balances air pressure within the heating, ventilation, and air conditioning systems to ensure optimal performance. Then we have automotive testing, which wherein we measure the pressure in engine components such as exhaust systems and other automotive parts for performance tuning and diagnostics. We have meteorology, which a part of barometers usually use manometers to measure atmospheric pressure and aids in using weather forecasting in weather forecasting. Next is aerospace, monitors cabin pressure and other critical pressure measurements in the air in the aircraft to ensure safety. And lastly, in different factories and industrial processes, it monitors and controls pressures in pipelines, reactors, and other industrial machinery to be able to maintain safety efficient. So lastly, we have an example. So we have if the atmospheric pressure of a 760 millimeter mercury, what is the pressure of the gas in a manometer if the mercury column is 60 millimeters higher on the other side, or if it is 50 millimeters lower on the other side? So, given that we have 760 mm of Hg, without even needing to use our absolute pressure, because we already know that the mercury column is already 60 millimeters higher on the atmospheric side, we know that the gas is pushing down a stronger amount of area than the mercury column. So we know that we need to add 760 millimeters to 60 millimeters. So we get the answer of 820 millimeters of mercury. Next, what if our mercury column is 50 millimeters lower than our atmospheric side? That would mean that we have given 760 millimeters of mercury. Since our mercury side is heavier than the gas side or the pressure of the gas, we need to reduce or deduct 760 by 50, which gives us 710 millimeters of mercury. That is all for my presentation. Once again, I am John Camilo B. Dichoso. Thank you for listening.